Hi, I'm Bob. Welcome back to 5 Minute Econometrics. Today, we will explore discrete outcome variables and how to interpret coefficients in a linear regression model. A discrete variable can take on only a limited number of integer values, with 0 being a common value. Some examples include the number of children under 6 in a family, the number of times a person was arrested in a given year, and the number of times a person travels abroad in a given year. When a discrete variable is used as the outcome variable in a model, it is referred to as a discrete choice model or a limited dependent variable model. An extreme example of a discrete choice model is the binary response model, which features a dummy outcome variable that can take only two values, 0 and 1. Today, we will focus on discrete outcome variables that take on a small number of integer values. Since the model differs from using a continuous outcome variable, it is essential to pay close attention to the interpretation of the OLS coefficient estimates. Here is an example. We model educational attainment, age, and whether living in a home with electricity to explain how many children were born to a woman. The outcome variable, children, is a discrete variable. We can use the summarize command to find the average, maximum, and minimum number of children in the sample. The sample mean is 2.27, with a minimum of 0 and a maximum of 13. Notice that no woman has exactly the average number of children. The average of 2.27 children means that if we randomly choose 100 women from the population, we expect to find 227 children in their families. Since children is a discrete variable, we can also use the tabulate command to find the frequencies. Children has 14 integer values, ranging from 0 to 13. About 26% of the women did not have children in the sample. We can find the information about age and education using the summarize command. The dummy variable electricity denotes whether the woman lived in a home with electricity. For dummy variables, we often use the tabulate command to find the frequency and percentage for each category. We regress children on the three explanatory variables. I write the estimated equation in a normal form. Let us interpret the coefficient estimates. The estimate for education is minus 0.079. If we take this estimate literally, it says that each additional year of schooling reduces the estimated number of children by 0.079. It is obviously impossible for any particular woman. To make sense of the estimate, we should interpret it as an average. Remember that under the multiple linear regression assumptions 1 to 4, especially the zero conditional mean assumption, the expected value of the outcome variable conditional on the explanatory variables is as follows. The coefficients, beta, are the effects of the x on the expected or average value of y. Therefore, The OLS estimates, beta hats, are estimates of how the average of y changes when the explanatory variables change by 1 unit. The estimate of minus 0.079 implies that for a group of 1,000 women, if each woman have 1 more year of education, then there will be 79 fewer children among these 1,000 women, holding other factors constant. The estimate for the dummy variable electricity is minus 0.36. Keep in mind that the dummy variable's coefficient is the difference in the outcome variable across groups defined by the dummy. Suppose we have 2 groups of 100 women at the same educational level and the same age. The 100 women with electricity will have 36 fewer children than the 100 women without electricity. Today, we touch on the topic of discrete outcome variables. When the outcome takes on only a small number of integer values, we interpret the OLS coefficient estimates in terms of the average. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.